Assalamu alaikum students. I hope you all are doing very well, and the topic today we are going to discuss about group 4 of the periodic table, and the elements of group 4A group are also known as carbon family. These elements are named as carbon family because the carbon is first most element of this group. That's why they are named as carbon family. And today we are going to discuss about introduction part of fourth group of periodic table, then about the trends in physical properties of carbon family. In physical properties, we will be discussing about trends in melting point, boiling point of these elements, and trends in oxidation state of these elements. So let's discuss them one by one. First of all, introduction part. Here we are going to discuss about metallic character, and then we are going to discuss the position of fourth group in periodic table. As we know, metallic character increase from top to bottom, as here is carbon is the topmost element member of this group, and the lead is last one. So from top to bottom, metallic character increased, that we have discussed in previous lecture. So if metallic character is increased, then the bottom elements must be metal. So it is happening. So you can see that it is written here, tin and lead both are metals, while carbon and silicon, which are topmost member of this group, they are non-metals, while the intermediate one is germanium, which is a one of metalloid. Metalloid has some of the non-metal properties and some of metals properties. That's why they are named as metalloid. And in this group, you guys, students must remember that germanium is metalloid. So next is about the position of fourth group in a periodic table. What is the position of fourth group in periodic table? It is said that it has intermediate position. So in what intermediate position? As you have we have discussed in previous lectures, that first A group and the second A group, which are alkali metals and alkaline earth metals respectively. So these two groups were electropositive groups. So third here you can see third A group is also electropositive. So first A group to third A group, these three groups in periodic table are more electropositive, while we are moving onward from 5A group to 8A group, it is said that these are more electronegative group. And the fourth group is not more electropositive, and neither it is more electronegative, while it is intermediate. So now heading toward trends and physical properties of these elements. First of all, we are going to discuss trends in melting point and boiling point of carbon family members. So expected trend is shown here, that expected trend should be like that topmost element should have high melting point and boiling point, while the lowermost should have low melting point and boiling point, because bond strength is metallic bond strength is going to decrease from top to bottom. Metallic bond strength is going to decrease from top to bottom. If metallic strength is increased, then they should easily melt and boil at lower temperature. That's why they must have low melting point and boiling point. But it is not in actual it is not happening so. There are some trends in melting point and boiling point, as you can see in a graphical representation. The red lines are showing you trends in boiling point, while blue lines in graph are showing you trends in melting point. As you can see, students, that trends in melting and boiling point are not so regular, because if it is going to decrease for second member, then it is going to increase for third and fourth member of the carbon family, and then it is going to decrease for lead. So it means it is not regular. So here we can see the red lines, that carbon is highest boiling point, then silicon has lower than germanium and tin, which is against the expected trend of boiling point. The reason here we will study that why germanium and tin have higher boiling point than silicon. So short question can be asked like, why boiling point of germanium and tin is higher than that of silicon? So the reasons are that silicon, when actually silicon exists in a network form. When we provide the temperature to solid form of silicon, then it get melted. When it get melted once, then there will be weak London dispersion forces in melted form of silicon. So if now it is melted with the which is molten form of silicon is having weak London dispersion forces, then these forces are weaker, and these weaker forces will require low temperature to break down for boiling. So that's why at lower temperature molten form of silicon get boiled. So that's why we say that silicon has lower boiling point. While we are discussing about germanium and tin, they have strong metallic bond in their molten state. In their molten state, they have strong metallic bond. So if metallic bonds are stronger, then they will require more temperature to break down and to convert into vapor state. So that's why we say that germanium and tin are having more boiling point than the silicon. Here is also the case where we can see a bond strength comparison between two different kind of forces. One is metallic bond and another is London dispersion force. You can see clearly that metallic bond is stronger than London dispersion force. So metallic bond for its breakdown will require more temperature so than the London dispersion forces. That's why metallic bond containing compounds have higher melting point or boiling point than London dispersion forces. Another case is trends in boiling point. First of all, carbon has highest melting point. Blue lines are showing you trends in melting point. So carbon is again having highest melting point. After that has silicon. It is somewhat regular pattern than in the case of boiling point. So first of all, carbon has higher than silicon. Silicon is higher than germanium. Germanium is higher than tin, but tin has less than lead. It should not, you can see that it is against the regular pattern or expected trend in melting and boiling point. In actual, it should happen that lead should have a lower most value of melting point even than tin, but it is not in actual. Tin has lower than lead. So it can also be in the form, it can be also asked from you in the form of short question or either in form of MCQs. So when it is asked as a short question, they can ask why lead has high melting point than tin, or they can also ask that why tin has lower melting point than lead. So there are following reason that in the case of lead, their f orbitals are causing poor shielding effect. If there will be poor shielding effect, then there will be greater nuclear charge. Greater nuclear charge mean it will attract another electron. mean होगा ऐसे कि बच्चे अगर पॉजिटिव चार्ज ज़्यादा है तो इसके कंटेक्ट में कोई ऐसा आइटम आता है जिसके पास इलेक्ट्रॉन है, तो ये पॉजिटिव चार्ज उसको इफेक्टिवली अट्रैक्ट करेगा. जब अट्रैक्ट होगा तो शेयर करके ये क्या कर लेंगे, बॉन्ड बना लेंगे. ठीक हो गया. जब बॉन्ड बना लेंगे तो इट्स मीन ये स्ट्रॉन्गर बॉन्ड होगा. जहाँ पे शील्डिंग कम है और tin में शील्डिंग ज़्यादा है, तो इसका बॉन्ड इतना, इसका न्यूक्लियर चार्ज कम होगा, वो इफेक्टिवली दूसरे आइटम के इलेक्ट्रॉन को अट्रैक्ट नहीं करेगा. तो वीक बॉन्ड होगा tin के केस में और lead के केस में स्ट्रॉन्गर बॉन्ड होगा. सो दैट्स वाई टू मेल्ट lead it will require more temperature than in the case of tin. So that's why we say that lead has higher melting point than tin. So students, next we are going to discuss is about oxidation state of carbon family members. First of all, you should know that what is oxidation state. Oxidation state is apparent charge on an atom or ion or a molecule. That apparent charge of that atom, ion or a molecule is known as its oxidation state. As we are going to discuss trends in oxidation state of fourth group A of periodic table or carbon family members, so we can say that carbon family members show both positive and negative oxidation states. They show both positive and negative oxidation state. While we were discussing about first A group and second A group, we have not discussed about negative oxidation state. We were just discussing that they are showing only positive oxidation state, like alkali metal were showing +1 oxidation state. Similarly, alkaline earth metals were showing +2 oxidation state. But here in fourth group, you can see that its members show both positive and negative oxidation state. And the most common, every group has most common oxidation state, and then few of members show variable oxidation state. So same is happening here, that these groups show most common oxidation state, that is +4. And you must know that MCQs can be asked about fourth group or carbon family members, what like that, what is their common oxidation state. So you must know that common oxidation state is +4. And another thing I want to tell you, students, that on the top of group, most common oxidation state is +4, while as you will move down to the group, there will be most stable oxidation state +2. So here are members like tin and lead, which are showing variable oxidation state. Similarly, carbon is showing variable oxidation state. But you must know that silicon only shows +4. Here I have draw a arrow, so which is showing that silicon only show +4. I can write here only plus, but carbon show +4, as well as many others are also mentioned here. So when we discuss about tin and lead both show +2 and +4 oxidation state. Okay, but in the case of tin, +4 is stable. That's why I have written here plus tin symbol. But in the case of lead, +2 oxidation state is common. As we have discussed that on the bottom of the group, the elements must have +2 oxidation state in the stable form. So this is what happening here. The lead is lower most element, and it is having +2 oxidation state, while carbon show different kind of oxidation state, like +4, -4, +2, -1. In the case of beryllium carbide, it is showing -4, while in the case of sodium carbide, it is showing -1. So there can be different MCQs. Students, another important thing is that other members do not show negative oxidation state. You must remember only carbon show negative oxidation.